Hello, welcome standard 12 students. So today I am going to discuss the chemical properties of nitric acid. This chemical properties of nitric acid, it's very important. It is likely to be asked in the exam. Totally nearly we have chemical properties like 10 to 12. Okay. So these are the first sixth property. Now see here. The first property is that aqueous solution of nitric acid is a strong acid. Which the aqueous solution of nitric acid is a strong acid. Why? Because it gives, any substance when dissolved in the water, if it gives H plus or H3O plus, they are an acid. So whenever the nitric acid is dissolved in the water, it will yield what? It will yield H3O plus and nitrate ion, that is NO3. So it contains H3O plus and NO3 minus, means this HNO3 is a strong acid. So see, if I take this HNO3 and if I dissolve in the water, I will get what? See, this I will get here H3O plus and NO3 minus. So any substance yielding H plus or H3O plus, such a substance are known as a what? Acid. So first point is the aqueous solution of a nitric acid is a strong acid because it yield what? H3O plus and NO3 minus. If you see here, so see this H2O and this is an HNO3. When it goes in the water, it forms H plus and NO3 minus. This H plus when react with this water. So in water there is one oxygen. Oxygen is having a 2 lone pair. Out of 2 lone pair, 1 lone pair will react with this H plus and forms what? H3O plus and forms NO3 minus. This everything you know. So this any substance when in its aqueous solution, if it yields H3O plus or NO3 minus, so such a substance are known as a what? Acids. So first point is clear that aqueous solution of a nitric acid is a strong acid. Yes or no? That's why we say a nitric acid is a strong acid. Why strong acid? Because it yields what? H3O plus or H plus in its aqueous solution, like H2SO for HCl. Clear? So first point, aqueous solution of nitric acid is a strong acid. It contains H3O plus and NO3 minus, and this is the reaction. Clear? Next point. In standard 10 we have studied that metal plus acid gives metallic salt plus hydrogen gas. So in that acid there was an exception. The acid exception was nitric acid. Nitric acid does not give hydrogen gas with every metal. Instead of hydrogen gas, nitric acid was used to give water, NO or N2O or NO2. Only except few metal with nitric acid only yields the hydrogen gas. So you know that metal plus acid gives metallic salt plus hydrogen gas. But in that acid there was one exception, and exception was nitric acid. Nitric acid will not give hydrogen with every metal. Instead of hydrogen, it was used to yield H2O or H2O and other some more extra oxide of nitrogen like NO, N2 or NO2. There is one reason, due to the HNO3 is a strong oxidizing agent. We have studied in standard 10. Yes or no? Last class also I told you that nitric acid is a strong oxidizing agent, and I told you the reason also. Clear? So second point, but nitric acid with every metal, see, sulfuric acid with every metal will give hydrogen gas and salt. HCl with every metal will give hydrogen gas and salt, but nitric acid with every metal will not give salt and N2O or water. But there are certain metal like Mg, Mn, Ca. So there are certain active metal like Mg, Mn, Ca. This is very important MCQ. Okay, this MCQ is very important, that there are certain metal like Mg, Mn, Ca. When they react with nitric acid, so it will yield hydrogen gas plus metal nitrate. But other metal like copper, zinc, so with copper, with zinc, it will not give hydrogen gas. Instead of hydrogen gas, it will give water and extra oxides. But with the metal like Mg, Mn, Ca, the nitric acid will give hydrogen gas. You have to remember this. Okay. So see here, metal like Mg, Mn, Ca gives hydrogen gas on reacting with nitric acid. Whereas other metal than this Mg, Mn, Ca, whereas other metal like zinc, I will do the reaction. Okay, like zinc, like copper. There are many other metal and also non-metal also. So whereas other metal gives H2O along with NO, N2O, NO2 or NH4, NO3. This NH4, NO3 is with SN. I will write down just now, don't worry. Okay. So what I told you, see, understand this second property is very important. We have studied in standard 10 that metal plus acid, metallic salt plus hydrogen gas. In that acid, nitric acid was an exception. Nitric acid will not give hydrogen gas with every metal. Instead, it was used to give H2O along with certain oxide like NO, N2, NO2 because the nitric acid was strong oxidizing agent. We have studied that in the standard 10. Last class I also explained you why nitric acid is a strong oxidizing agent because of the +5 oxidation state. This I have explained it, okay. But there was one exception, that nitric acid with a metal like MgMnCa will yield hydrogen gas. So you have to remember this, that metal like MgMnCa gives hydrogen gas on reacting with nitric acid, whereas other metal than this will give H2O. Why H2O? Because strong oxidizing agent. Who? Nitric acid along with NO, N2O or NO2 or NH4NO3, and this NH4NO3 will come in tin. I'll write down, I will do in this class only, clear? Don't worry. Next, sugar on reacting with nitric acid gives oxalic acid. Sugar on reacting with nitric acid gives what? Oxalic acid. You have to remember this, okay? So sugar means what? C6H12O6. Yes or no? Sugar means C12H22O11. Sorry, it is glucose. So sugar means C12H22O11. It will react with nitric acid, and this nitric acid will provide nascent oxygen. This nitric acid will provide what? Nascent oxygen. Due to the presence of this nascent oxygen, this sugar in the presence of nitric acid will convert into the oxalic acid, that is COOH. Clear this part? So write down this, that what you write down, and you can balance the reaction of your own, okay. So sugar on reacting with nitric acid gives oxalic acid. So this is a sugar, yes or no? This portion is a what? This is a sugar, will react with what? Nitric acid, and this nitric acid will gives what? This nitric acid will give nascent oxygen. Due to this nascent oxygen, this sugar is converting into oxalic acid. So that's why I have written this point, that is the sugar on reacting with nitric acid gives oxalic acid. So whenever sugar react with nitric acid, so nitric acid, as soon as it reacts with sugar, it will starts to yield nascent oxygen. That nascent oxygen is responsible for the yielding of oxalic acid. Clear this part? Next point, nitric acid on reacting with glycerin gives nitroglycerine. Okay, so HNO3 on reacting with glycerin gives nitroglycerine, and with toluene gives TNT, which is used as an explosive, and you are not new about it, you are done in hydrocarbon, okay. And with cellulose, it will give the gun cotton. Clear? That is cellulose trinitrate. So this portion is also very important, that HNO3 on reacting with glycerin, gives nitroglycerine. With cellulose, it will give gun cotton, that is cellulose trinitrate, and with toluene, it gives TNT, that is trinitrotoluene. Clear this part? So fourth point is what? That HNO3 on reacting with glycerine gives nitroglycerine, and with toluene it gives TNT, and this TNT is used as explosive, and with cellulose it will give the gun cotton, that is known as a cellulose trinitrate. So please student remember, cellulose trinitrate is nothing but a gun cotton. Clear? So what is the fourth point? That nitric acid on reacting with glycerin gives nitroglycerine, with toluene gives trinitrotoluene, and with cellulose it will give the gun cotton, which is known as a trinitrite. Clear? Now fifth point is very important, that is passivity. What do you mean by passivity? Means, see, metal like chromium or aluminum, when they are made to react with nitric acid, when they are made to react with nitric acid, initially for a few minutes they will react. After that, after some time, the reaction will start to stop. Why the reaction starts to stop? Because aluminum and chromium will form their oxide layer. Now that oxide layer will act as a protective film for the metal to go for the further reaction. That's why I have written here that metal like chromium, aluminum reacts initially with nitric acid. Then further the reaction stop. Why the further the reaction stop? Due to formation of passive layer of their oxide layer. Passive layer means the layer which will ask to stop to do the reaction. Clear? So see, if you drop some portion of acid on aluminum or on a chromium, initially they will start to react, but after some time automatically you will see that the reaction stops. Why the reaction stop? Because they starts to form their oxide layer. Who? Aluminium and metal like aluminium and chromium. They will start to form their oxide layer. Now that oxide layer which is formed due to the reaction with nitric acid, now that oxide layer will act as a passive layer, means they will act as a protective layer, so that the further reaction will stop. So this, remember this point, that metal like chromium, aluminium reacts initially with nitric acid, then further reaction stop. Why the further reaction stop? Due to the formation of passive layer of their oxide. Clear this part? Next, this sixth point is very important, that nitric acid on a long standing, if you keep a nitric acid as it is, okay, in an open, or you keep in an open bottle, suppose you are opening the bottle and keeping as it is, after certain days what you will see? You will see that nitric acid has attained yellow color. That nitric acid has attained yellow color, and that yellow color is due to what? That yellow color is due to the impurity of NO2 dissolved. That yellow color is due to what? Impurity of nitrogen dioxide dissolved automatically. See here. So concentrated nitric acid on long standing attains yellow color due to dissolved nitrogen dioxide. See here, this nitric acid, if you keep open, it will start to react with sunlight, that is H mu, and it will forms what? NO2, H2 and O2. This O2 will start to remove, and this NO2 nitrogen dioxide which is formed due to the sunlight will get dissolved in the nitric acid and gives the color yellow. Now if you want to decolorize this yellow color, what you have to do? You have to take this yellow color acid and you have to warm. You have to warm at nearly 60 to 80 degrees Celsius, and you have to pass the air. What you have to do? You have to pass the dry air. When you pass the dry air, it will again comes to the colorless portion. It will again come to the colorless. Okay, means nitric acid will get pure. So see, concentrated nitric acid on a long standing will turns into what? Will turns into yellow color. Why? Because the concentrated nitric acid on long standing will starts to react with what? Sunlight, that is H mu. As soon as the nitric acid starts to react with sunlight, it will forms NO2, H2 and O2. This NO2 will get dissolved in the nitric acid and turns that colorless substance into the yellow color. So yellow color substance is due to what? Yellow color substance is due to the impurities of nitrogen dioxide. Now if you want to remove this yellow color, then what you have to do? You have to take that yellow color acid and you have to warm on nearly 60 to 80 degrees Celsius, and during warming you have to bubble the dry air. You have to bubble what? Dry air. When you bubble the dry air, automatically it will turns into the white color. Write down this portion, you write down, please write down. First you do one thing, you take a screenshot, or you can pause button, you write down here, and after this 6 point write down here one question, write down. Chalo, first you do the screenshot, or you take pause the button, then write down this, then I write down this 6 point. So written everyone. Now see here, write down 6 point, write down. Come on, take out your book. The yellow color of nitric acid, is removed by warming the yellow color acid, at nearly 60 to 80 degrees Celsius, and bubbling dry air through it, Clear? So concentrated nitric acid, please remember this question has been asked, okay, that concentrated nitric acid turns yellow on long standing. Why? So, and how can you remove that yellow color? So concentrated nitric acid turns yellow on a long standing due to dissolved impurities of nitrogen dioxide, that is NO2. And how you get it? That HNO3 starts to react with what? Sunlight. When HNO3 starts to react with sunlight, it will form what? NO2, H2 and O2. This NO2 will dissolve in that nitric acid and turn slowly that nitric acid colorless into yellow color. Now how to remove that yellow color? What you have to do? You have to take that yellow color acid and you have to warm at nearly 60 to 80 degrees Celsius, and you have to bubble the dry air. When you start to bubble the dry air, slowly, that yellow color part will be removed. Clear this part? So these are the 6 property. Please note it down, then we'll go to the next property. Now see here, so again this portion, it's bit confusion and bit difficult also, okay. So you can see here I have written the general reaction, metal plus nitric acid, but nitric acid is dilute, then it will give metal nitrate, N2O or NO. Now N2O will come or NO will come, it depends on how much it is diluted. Highly diluted means more amount, means say 5% of acid and 95% of water, means highly diluted. Or another dilution can be like 10 to 30% acid and remaining 70% 10 to 30% acid and remaining percentage water. So it depends on how much dilution. Highly diluted means it will give N2O. Okay, highly diluted. Less diluted means it will give NO. So you have to remember the MCQ in this way, that metal plus nitric acid will give metal nitrate plus N2O plus NO. Now whether it will give N2O or whether it will give NO, it depends on how much it is diluted and plus water. So this portion, no, it becomes a bit difficult. So you have to remember here. Next comes metal plus nitric acid. This nitric acid is concentrated. Now when it is concentrated, it's very easy. It will give metal nitrate, and you know metal plus acid gives metallic salt plus hydrogen gas. But this is the nitric acid, and nitric acid is a strong oxidizing agent. So instead of hydrogen gas, it will give water and one extra product of its oxide. So here oxide will be nitrogen dioxide. So these two reactions, if you remember the general reaction, you can remember all the reactions. Are you understanding? So see, first reaction is what? That metal plus nitric acid gives metallic salt, that is metallic nitrate, plus water and plus one of its oxide. Now if it is diluted, so either it will give NO or N2O, either it will give NO or N2O when in the dilution case. Now the question comes, when it will give N2O, when it will give NO. So it depends on how much it is diluted. Highly diluted, it will give N2O. Less diluted, it will give NO. We will see this. Second point, metal plus nitric acid. Now this nitric acid is concentrated, so it will give metal nitrate plus hydrogen gas. Instead of hydrogen gas, it will give water and plus one of its oxide. But here oxide is fixed. Which is the oxide here? Nitrogen dioxide. So in concentrated nitric acid, oxide is fixed, that is nitrogen dioxide. But in dilute, it is not fixed. It can be NO or N2O. Either of one can come. It depends on how much it is diluted. And you can take here metal as Cu, Hg, Ag, Pb. This metal here. Here any metal, but here the metal will be less reactive metal. You know, highly reactive metal, like I told you example, MgMn. Highly reactive metal, no, MgCa. Sorry, not Mn. MnCa. These are the highly reactive metal. If you react that highly reactive metal with HNO3, it will give hydrogen gas. But all the metal will not give hydrogen gas. Okay. So here metal you can give the example of Cu, Hg, Ag or Pb. Okay. Au will not react with nitric acid. AuPt will not react with nitric acid. AuPt will not react with nitric acid. So then what to do? I will discuss in this video only. Okay. So see here, less reactive metal like Cu, Hg, Ag, Pb. Here Au and Pt will not come. Clear? So when reacted with concentrated nitric acid, so here the product is fixed. Metal nitrate, water and nitrogen dioxide. In only diluted portion it is not fixed. Either NO or N2. Now we will see this. Now see. This copper, I am taking the example of copper, okay. You can here take the example of Hg, Ag, Pp, but you take most of the time in the example are coming with copper only. So do not worry about it. Clear? Now see here. Copper when reacted with nitric acid, and this nitric acid is highly diluted, okay. Highly diluted. So it will give copper nitrate, and when it is diluted, it will give N2O. It will give what? N2O. Now see here. Here nitrogen oxidation number is +5. And here nitrogen oxidation number will be, you can see here, so N2O, so 2N plus O equal to 0. So 2N minus 2 equal to 0, N is +1. Yes or no? So +1. Now see here, 5 to 1, decreasing or increasing? 5 to 1, it is decreasing or increasing? Decreasing means reduction. And one who does is an oxidizing agent. See, here also nitric acid is showing that I am the strong oxidizing agent. So if in the exam question can come, prove how nitric acid is a strong oxidizing agent by the reaction. You can write down this reaction and you can show. See, a nitrogen oxidation number in HNO3 will be +5, but in N2O oxidation number is +1. So 5 to 1 reduction, and one who does the reduction is an oxidizing agent. Now second reaction, see, same copper, but if I react with nitric acid, now nitric acid is 10 to 30% diluted. Here it is highly diluted, say 2 to 3%, okay. 2 to 3% water, 2 to 3% acid, remaining water. Here 10 to 30%, means 10 to 30% acid, remaining is water. So this nitric acid is bit more concentrated than this. but as compared to this is like diluted. Okay, so here dilution is nearly 10 to 30%. So when I take the same copper and if I take the nitric acid, which is 10 to 30%, instead of N2O I'll get NO. That's why I told you that metal plus nitric acid, if nitric acid is diluted, it will give metal nitrate, N2O or NO. It depends which oxide will come, it depends on how much diluted. So highly diluted N2O, less diluted NO. Clear? If you see here also, here nitrogen oxidation number is +5, but here nitrogen oxidation number will be +2. So again +5 to +2, students say what happens? Reduce or decrease or increase? Decrease means what? Reduction. Again he is showing the example of what? Oxidizing agent. Clear? So first is copper when reacted with nitric acid, which is highly diluted, it will yield N2O, metal nitrate plus hydrogen. Instead of hydrogen it will give water because strong oxidizing agent. Similarly copper with nitric acid, but it is 10 to 30% diluted. When 10 to 30% diluted, instead of N2O it will give NO. So you have to remember, if highly diluted N2O, less diluted NO. Remember, it will come. So this is highly diluted means N2O, less diluted means what? Highly diluted means more amount of water, N2O, less amount of water, NO. Clear? Now see, same copper if I react with concentrated nitric acid, and with concentrated it is metal nitrate, NO2, H2O fix. So you also see copper plus nitric acid, if it is highly concentrated, copper nitrate means metal nitrate will come plus NO2 plus H2O. Clear this part? So this reaction clear? Now there are reaction of a zinc. Yes or no? I can take here example of a zinc also, and in your book zinc example have been given many a times, especially with cold and hot. So now see here, zinc plus nitric acid. First see here students, see zinc plus nitric acid. Now here nitric acid is diluted. Clear? So if you come to the diluted portion, either it will come N2O or NO. So now see here, zinc plus nitric acid, it is diluted. If I take hot, so it will come zinc nitrate plus N2O plus H2O. See, it is there N2O. Means dilute means what? N2O. So zinc plus nitric acid, and nitric acid is diluted, but it is a hot diluted. It is not cold, it is hot. If I take hot, I will get zinc nitrate, N2O and H2O. But if same dilute nitric acid, if I take cold, instead of N2O I will get ammonium nitrate. In my previous slide I have written ammonium nitrate. So you have to remember this reaction, it's very important, that when zinc react with dilute nitric acid, if it is hot, it will form N2O, but if it is cold it will form ammonium nitrate. So this portion you should remember. Clear? Again if you see here +5, but here also again what? How much? +1. Again he is showing that I am a strong oxidizing agent. So zinc on reacting with dilute nitric acid, but here the condition is two conditions, there is hot and cold. If it is an hot nitric acid, it will form N2O. This product you should remember. But if it is a cold dilute nitric acid, it will form ammonium nitrate. And here one more example can come for tin also. If tin also react with nitric acid, it will also form ammonium nitrate. If tin also react with nitric acid, it will form ammonium nitrate. But if tin react with concentrated nitric acid, see, tin reacts with dilute nitric acid, either hot or cold, it will give ammonium nitrate. Who? Tin, SN. But tin, if it is a concentrated nitric acid, it will give metastenic acid, that is H2SNO3, and concentrated means what byproduct will come? NO2. So instead of here salt, acid will come only for what? Tin. Clear? So to remember that tin on reacting with nitric acid gives metastenic acid. Write down this formula. H2SNO3 means metastenic acid. Its name is what? Metastenic acid. So tin on reacting with concentrated nitric acid, it will give, now this portion is concentrated. When this portion is concentrated means in product what will come? NO2. When NO2 comes here, so SN plus HNO3, this concentrated means here nitrogen dioxide will come. But instead of salt, it will form H2SNO3. This is an exceptional behavior of tin. So tin on reacting with concentrated nitric acid will form metastenic acid, nitrogen dioxide as per the concentrated portion, and water. So these are the property of metal plus nitric acid. Now we are going to see the property of non-metal plus nitric acid. Write down, take a screenshot, then we'll move to the next topic. So now see here, so next property is that concentrated nitric acid when reacted with non-metal, so it get oxidized. Who get oxidized? nitric acid get oxidized and form their respective acid. Whose respective acid? This non-metal respective acids. Clear? So whenever concentrated nitric acid will react with non-metal, so nitric acid get oxidized to form NO2, okay, and they form the respective oxide of the non-metal. Now see here, so non-metal plus nitric acid, and here nitric acid to take concentrated. Please remember this, non-metal plus nitric acid, and this nitric acid should be taken concentrated, so you will get the respective acid of non-metal. And you know non-metallic oxide are acidic in nature. So respective acid of the non-metal, nitrogen dioxide. Why nitrogen dioxide? Because the concentrated. Yes or no? And plus water. What will get? Water. See the example. Iodine. Iodine is a non-metal and this HNO3 is concentrated. So what I will get? I will get the respective acid. So I will get HiO3. This is known as an iodic acid. It will come in the future classes. So HiO3. I will get the iodic acid plus NO2 plus water. Now see here N is plus 5. Okay, here if you take N is plus 4. Again 5 to 4, decrease or increase? Reduction. Means this is again he is showing the example that I am the oxidizing agent. I told you no, nitric acid is a strong oxidizing agent. Here if you see iodine is 0, but here if you see HiO3 means 1 plus I minus 6 equal to 0. So I will be equal to I minus 5 equal to 0. I will be equal to plus 5. So here iodine is plus 5. So see here students, 0 to plus 5, increase or decrease? It is increase, means oxidation. So this is also an example of an redox reaction. Clear? You can balance of your own. Okay. See, this is not a balance equation. Okay, you can balance it. Clear? Again sulfur, acid. Yes or no? This is also non-metal. So when reacted with nitric acid, so it will produce what? Acid. And which is the acid related to sulfur? H2SO4. Clear? And again this acid is what? Concentrated. And plus NO2. Why NO2? Because this is concentrated nitric acid plus H2O. Clear? Phosphorus when reacted with concentrated nitric acid, again which is the acid related to phosphorus? H3PO4. So this H3PO4 is an acid, nitrogen dioxide plus water. So remember this point that nitric acid, see there are variation with metal only. There is no variation with non-metal, and this question can be asked. You can take always concentrated nitric acid. Clear? So nitric acid when reacted with concentrated nitric acid whenever reacted with the non-metal, it will give what? It will give their respective acid. Whose respective acid? Non-metal respective acid. Sulfur means sulfur acid. Chlorine, here I can take chlorine also. So I will get here chloric acid, HClO4. Okay. So with non-metal they will give the acid, their respective acid, like sulfur, sulfuric acid, iodine, iodic acid. Here carbon means carbonic acid, H2CO3 will also come. Yes sir. Phosphorus means phosphoric acid. Okay. Plus NO2. Why NO2? Remember concentrated nitric acid, NO2. Concentrated nitric acid, byproduct NO2. Diluted either N2O or NO. Now it depends on how much it is diluted, and plus water. Clear this part? So write down this, then we will go to the next portion, and that next portion is Aqua Regia. Clear? Okay, now see here. So last topic in the chemical properties, and there is one more topic that is a brown ring test. Okay, for the nitrogen I will do in the next class. Now see here, so my new topic is now Aqua Regia. Aqua Regia, or we can say as a royal water. Okay, now what is this? See students, before my in this class I told you that metal like AU and PT, metal like AU and PT, these two metals do not react with what? Do not react with HNO3. Yes or no? They will not react with HNO3. Who? AU and PT. Yes or no? Now, if I want to do the reaction of AU and PT, then what I have to do? So I have to form one mixture, and that mixture name is Aqua Regia or royal water. Clear? So I told you no, that the metals like AU and PT does not react with nitric acid. Yes or no? Clear? See that aluminum initially it also react, further the reaction stop, but initially they reacted. No, here though initially also will not react. They will not react itself only. When it is not reacted means nitric acid will act as a what? Strong, nitric acid becomes very passive towards AU and PT. It will not react. AU and PT will not react with nitric acid. But now I have to do the reaction of AU and PT with nitric acid. Then what I have to do? So I am creating one mixture, and that mixture name is Aqua Regia or royal water. Now what is this? Now this Aqua Regia or royal water is a one kind of a mixture. So it is a mixture of 1:3 proportion of concentrated HNO3 and concentrated HCl. Write down this. Chalo, write down. So it is a mixture of, write down this portion. It is a mixture of 1:3 proportion. It is a mixture of 1:3 proportion of concentrated nitric acid, and HCl. 1:3 proportion means 1 portion nitric acid and 3 portion HCl. In certain book they have written like this also, 25% nitric acid and 75% HCl. Student, one and same or not? See, check it out. 75 by 3, sorry, 25 by 75 means what? 1 by 3 only. Yes or no? So it is a mixture of concentrated nitric acid and concentrated HCl into 1:3 proportion. So in this mixture, and this mixture is known as a what? Aqua Regia plus, or we can say as a royal water, or just Aqua Regia or royal water. So whenever a metal like AU or PT, when reacted with Aqua Regia, reaction occurs. Yes or no? The reaction occurs. So I can write down here that AU or PT when reacted with Aqua Regia means here reaction occur. Clear? Now how the reaction occur, that we have to see. So write down this. Now we will see why the reaction occur and how the reaction occurs. See here now. Clear this part? Now see what happens. Now see why the reaction occurs. So it is a mixture of 1:3 proportion of what? So it is a mixture of 1:3 proportion of nitric acid and HCl. 1 part HNO3 and 1:3 proportion of nitric acid and HCl. 1 part HNO3 and 3 parts HCl. Now what happens? See, when you take HNO3, when you make Aqua Regia, so in Aqua Regia I have HNO3 and HCl. When they start to react together, they will form H2O plus NOCl plus nascent chlorine. They will react what? Nascent chlorine. So this is Aqua Regia. Okay, I will balance. You can balance the reaction of your own. So see, this is 1 portion, this is 3 portion. So whenever you make the Aqua Regia, whenever you mix 1 portion of HNO3 you take and 3 portion of HCl you take, you mix together. As soon as you mix these two mixture, you will form H2O, NOCl and chlorine. See, this chlorine is known as a nascent chlorine, monoatomic chlorine. This is highly reactive, I told you. See, Cl2, Cl, Cl. This is the bond. When bond cracks, so one electron if I give here and 1 electron if I give here, this is known as a nascent chlorine or monoatomic chlorine. We'll understand detail in the future classes. So whenever I am writing in the square bracket, this is a nascent chlorine or monoatomic chlorine, nascent chlorine. This is highly reactive. Okay, this is known as a nitrosyl chloride, and you can write down its reagent name NOCl. You can write down the Lindler's catalyst. I think you can write down the reagent name of NOCl. It is known as a Tilden's reagent. Okay, clear? So whenever you form a Aqua Regia, that is 1:3 proportion of HCl, so they two will react. Who to react? HNO3 and HCl, H2O, and forms NOCl. I say nitrosyl chloride or Tilden's reagent. Another name is what? Tilden's reagent, and this is a nascent chlorine. This nascent chlorine is responsible for doing the reaction with AU and PT. So here the nascent chlorine is responsible for doing the reaction with AUPT. Clear? I told you, no, see, with AU and PT nitric acid will not react. With AU and PT who will react? With AU and PT Aqua Regia or royal water will react. Why this Aqua Regia and royal water will react? Due to the reason when Aqua Regia is formed, they generate nascent chlorine. Now this nascent chlorine will react with that AUPT. So this nascent chlorine is responsible for the Aqua Regia to react with AU and PT. Now how it reacts? See here, whenever you react with this AU, with this Aqua Regia. Okay, so this Aqua Regia will give what? Nascent chlorine. This Aqua Regia will give what? Nascent chlorine. Now this nascent chlorine is coming from where? It is from Aqua Regia. Yes or no? This is from Aqua Regia, and this will form AuCl3. Clear? That's why, or I can write down this Au plus Aqua Regia. So Aqua Regia, it will form what? AuCl3. Why? Because the reason is this Aqua Regia is responsible to give nascent chlorine, and this nascent chlorine is reacting with gold. Clear? Au. That's why we are writing as a, what is the reaction I wrote? That Au plus Cl, and this nascent chlorine I got from where? This nascent chlorine I got from the Aqua Regia. Clear? So I got what? AuCl3. Similarly, if I take platinum and if I react with nascent chlorine, it will form PtCl4. Okay. Now this AuCl3, when reacted with HCl, which is excess. Clear? So you will get what? You will get orochloric acid, HAuCl4. Please remember this, orochloric acid. Clear? Similarly, if you react this PtCl4 plus HCl, and this HCl is what? Excess. So you will get what? Chloroplatinic acid, that is H2PtCl6. This is known as a chloroplatinic acid. Clear? So remember this. Okay, so what I told, what do you mean by Aqua Regia? Aqua Regia is nothing but a what? 1:3 proportion of a mixture of HNO3 and concentrated HCl. These two mixture are made to react with what? To react with noble metal like Au and Pt. Clear? Why it is reacting? That whenever HNO3 and HCl will react, it will forms H2O, NOCl, and this nascent chlorine. This is also Tilden's reagent. So this nascent chlorine is responsible for the reaction with gold. Clear? Or Pt, Au and Pt. So Au first will react with chlorine. This is nascent chlorine, and this nascent chlorine comes from where? It comes from Aqua Regia. It will form AuCl3. Now this AuCl3, when reacted further with HCl, it will form a gold compound which is known as a orochloric acid. Orochloric acid, HAuCl4. Clear? Similarly, this platinum when react with chlorine, this mono nascent chlorine, this nascent chlorine is also coming from where? From Aqua Regia. Yes or no? So from Aqua Regia, it will form what? It will form PtCl4. Now this PtCl4 when reacted with excess HCl, it will form what? Chloroplatinic acid. Chloroplatinic acid, H2PtCl6. So this you have to remember. Clear this part? So here the most of the chemical properties of nitric acid is over. If any it is remaining, you can please comment me so that I can go for the further. Now one more property is there which is very important, and that property name is brown ring test. This brown ring test I will do in the next class, and I will give the link also in the description so that you can see the live video. Clear? Thank you. Have a nice day.